Okay, guys, I just wanted to take the time to show you some of this documentation here on common agentic patterns. This is directly from the OpenAI agents GitHub here. If you got to this point and you haven't checked out the GitHub, make sure you do that. It has a lot of really, really good examples. But yeah, anyway, I just want to go through this documentation because it's really good. It's no point in me just doing it from scratch. We're just going to go through some of these code files here and just go over the different ways that you can configure your agentic applications. So the first one is a deterministic flow. This is the very first thing I showed you, where if we have multiple agents, we're not connecting them through handoffs. We're just connecting them by taking the output of the first agent after running it and using that to inform the input of the second agent and however many agents you want to have. That's why it's called deterministic, since you have manual control over what agents are executed and when. You kind of know exactly what's going to happen. So this example demonstrates a deterministic flow where each step is performed by an agent. The first agent generates a story outline. We feed the outline into the second agent, and the second agent checks if the outline is good quality and if it's a sci-fi story. If the outline is not good quality or a sci-fi or not a sci-fi story, we stop here. If the outline is good quality and a sci-fi story, we feed the outline into the third agent. So when we start the program, we start by running our story outline agent, which is just creating an outline of a very short story based on the user's input. So we ask the user what kind of story they want to make. We use that to create an outline, right? And then we feed that outline result into the second agent, which checks it as it said. So the second agent will read the given story outline and judge the quality, also to determine if it's a sci-fi story. So the way it's going to output that is by having an output type, which is another great way of having a deterministic flow of things, because since the output has to be of this type, we know exactly what to expect every single time. If, for example, you didn't have this, you would just get a string and you would have to hope or beg in the prompt for it to output it in this format of, this and this. So good quality bool and is sci-fi boolean. So based on that output, we determine if we want to go to the final agent, which is just actually writing the story using the outline result from the first agent. So yeah, hopefully that all makes sense. That's a deterministic pattern. This is great if you want a predictable flow of things. There's nothing wrong with using that. But if you want to, you can do more advanced stuff, which is handoffs and routing. This is essentially doing what we learned before, which is connecting agents together using handoffs and giving the router agent the capability of autonomously deciding whether it wants to route or not to a different agent. So it's a more automatic way of doing things. It's not deterministic because you don't exactly know what's going to happen every time, okay? So in this example here, we have 4 different agents. The last one here is the triage agent. This one is deciding which one to hand off to. So based on the language of the request, we route to different language agents, so French, Spanish, and English. So what makes this not autonomous, of course, like I just said, is the fact that the triage agent has to decide on its own what agent to route it to depending on the language. It has full control over what it wants to do, essentially. And the rest of this is just having a back and forth conversation with the agent after it's decided which one it wants to route to. So pretty cool. Another cool thing that you can do is use agents as tools. So the mental model for handoffs is that the new agent takes over. It sees the previous conversation history and owns the conversation from that point onwards. So what that means is that if you ever look at the traces for when you're doing the routing or the handoffs that we've done before, whenever it hands off to the agent doesn't return back to the previous agent. It gets inherited all the conversation history of all the previous agents and then just takes over from there, okay? So however, though, you can use an agent as a tool because as we know, if you ever seen a trace for a tool, whenever an agent calls a tool, it returns back the value from the tool to the agent to do whatever it wants with that information. We can use an agent as a tool so that the tool agent goes off and runs on its own and then returns back to the original agent. So for example, you can model the translation task above as tool calls instead. Rather than handing over to the language specific agent, you could call the agent as a tool and then use the result in the next step. This enables things like translating multiple languages at once. So let's check it out. And if you guys find this video helpful, please let me know. I'm just going over code like this. I just want to be as helpful as possible. Okay, so we have our 3 agents same as before, Spanish, French, and Italian. They all look the same. These are all the same, but then we have now an orchestrator agent. So this one has instructions. You are a translation agent. You can use the tools given to you to translate. So as you can see here, we have all the tools here, but no handoffs because we're doing the handoffs as tools. So for example, we're doing Spanish agent as tool, and then we're doing translate to Spanish, that's the name of the tool, and then the description, so it knows what to use it for, translate the user's message to Spanish. So essentially, again, we're just taking every single sub-agent that we would normally hand off to and using it as a tool instead, so that every time it effectively hands off to these agents, it actually returns rather than giving them full control. So it gives us the capability, if asked for multiple translations, you can call the relevant tools in order. Because as you know, when you're running an agent can actually call multiple tools or call the same tool multiple times before returning the final output. So it can do the same thing with this. If we have multiple languages that need translating, we could simply call multiple agents. So that's a really cool concept to play with for sure. Okay, now we have LLM as a judge. This is a really cool concept that you can use to improve the quality of an output. So large language models can often improve the quality of their output if given feedback. So a common pattern is to generate a response using a model and then use a second model to provide feedback. You can even use a small model for the initial generation and a larger model for the feedback to optimize cost. So, for example, you could use a large language model to generate an outline for a story, or an agent rather, and then use a second agent to evaluate the outline and provide feedback. You can then use the feedback to improve the outline or repeat until the large language model is satisfied with the outline. In other words, you can basically have one agent that produces an output, and then you can have a second agent that evaluates the output, and it decides on its own, is this good enough? If it's not good enough, it'll return back to the previous agent with feedback so that it could try again, and then it'll send it back to the evaluator agent to see if it's happy with the changes, and it can repeat that process for as many times as you want. You can even add a cap to it so it doesn't go on for too long. We're actually going to do a similar flow to this in our final project video, so stay tuned for that. By looking at the example here, we can see that we have our story outline generator, same as before. So you generate a very short story outline based on the user's input. If there is any feedback provided, use it to improve the outline. So here's the evaluator agent. So it's an agent. You evaluate a story outline and decide if it's good enough. If it's not good enough, you provide feedback on what needs to be improved. Never give it a pass on the first try. So you're telling it that it has to give feedback on the first try to make it as useful as possible. So we're going to return a specific type for this that has a feedback. So the actual string of the feedback that the first model can use to improve its outline. And then the second part is the score, which is pass, needs improvement, or fail, which we can then use to determine whether to go into the next part or not. Okay, so let's take a look at how that's implemented. So we're asking what kind of story do you want? We're feeding the story into our outline generator. And then basically what we're doing is we're taking the output of the outline from the outline generator and feeding it into the evaluator agent. And then we're taking the output from the evaluator agent and determining if it passed or not. So this is a deterministic flow in a sense. We're going to take the output, determine if it's pass. If it's pass, we're going to break the loop, and there's our story. It's good enough. If it did not pass, what we're going to do, this is kind of a cool trick you can do. Instead of having it re-invoke the story outline agent in a different way, what it's going to do is actually add on to the conversation history that we're going to feed into the outline generator. So we're going to add a message that says content and then the actual feedback from the evaluator agent. So basically for the next iteration of this loop, we're going to generate an outline again, same as before, except that we're going to have the original story that it wants to create along with the feedback that was generated by the evaluator. And it's just going to repeat that process over and over and over until the evaluator is satisfied. So I hope that wasn't too confusing, but that's pretty much all I'm going to show you. You also have one called parallelization and guardrails. We went over guardrails, and then you can look into parallelization if you want to, but these are the main ones that I really wanted to show you guys because now that you got this far in the series, you guys know how to make, all kinds of agents and stuff like that, but actually knowing how to build a flow or use common agentic patterns will actually make it so you can make these applications and not be confused on how to do stuff, right? So I really hope this is helpful. Please let me know if anything was confusing or if I went too fast or anything like that. Yeah, your feedback is very helpful. So I'll see you guys next time.